Good morning and afternoon, pre-calculus. That's my shout out to my 7th period peeps. Let's check out section 4.6. 4.6, composite. I really need to learn how to spell. This is embarrassing. Composite trig functions. Like that's going to happen. And remember, every function starts with fun. Huh? Okay, so composite trig function means we're going to put trig functions together with other things. This is going to be a little less technical and a little more graphical than what we've been doing. So go ahead and get your calculators out. And we're going to burn some calories on those. So the first thing I want to do is consider. And I'll just go ahead and put a y1 and a y2 there. Consider y1 and y2. y1 is sine x squared, and y2 is going to be sine of x squared. Whoops. Okay, so you can see they're pretty closely related. I just put that squared at a different spot. The question is, which is periodic? So which one of these functions has a period? Which one of these functions always repeats after a certain amount of time or after a certain amount of room? So let's go ahead and graph them both and see what we get. So let's see which one of these is periodic. Maybe you should second plus 7, 1, 2, or not, whatever. So I'm going to have sine x squared on the outside and then sine of x squared. Okay, so remember when you're graphing, y1 will come first and then y2. So there is y1. You know, I can't see that very well. I'm going to zoom trig. Zoom trig. Zoom trig. And so zoom trig goes from -4 to 4, and I think it's from -2 pi to 2 pi. And, okay, we have the first function there. Maybe I shouldn't have graphed them together. So that first function definitely looks periodic after it repeats itself, the same exact thing after looks like after pi. So let me look at my window. So when I zoom trig, went from -6.15 to +6.15. That's about 2 pi. Okay, 3.14, double it, that's 6.2. So that's about 2 pi. So, yeah, 2 pi. So that y1 looks like it repeats itself after pi. y2, well, you can see it kind of changes, right? This is x squared, so this graph starts to grow at an increasing rate, and as you go to the right, it oscillates quicker and quicker and quicker. Oscillates is that when it repeats, it oscillates. So I would say that the first function was periodic and the second function wasn't, because the second function didn't repeat in the same way. So y1 was periodic. And I could say its period is pi. It repeats after pi. y2 didn't have, well, you could say it has a period, but that changes. That period always gets smaller. So we don't really say that it does have a period. Because it changes, it doesn't have a period. Consider... Just consider, you know, we're just thinking here, right? Consider f of x is equal to 0.3x plus sine x. So when I say composite trig functions, we're just taking our trig functions and we're doing stuff to them. So this is something that we can do to a trig function. We can add 0.3x. Now normally when you have sine, it goes between the lines y equals 1 and y equals -1. So if I just had sine of x, let me go back here. If I just had sine of x, and if I put -1 and 1, there's our friend sine x, and it's going to go between -1 and 1. And so if I graph those lines, I graph that line. So when you see a problem like this, it usually asks you, well, what are these lines now? What is it? What are the two lines that the graph oscillates between? Okay, well, it oscillates between... Oscillates, do I have that spelled O-S-C-E-L-L-A-T-E-S? It oscillates between and this is pretty easy to do algebraically, the maximum of a sign is 1 and the minimum of sign is -1. So plug in 1 and -1. It oscillates between the line y equals 0.3x plus the maximum, which is 1, and y equals 0.3x plus the minimum, which is -1. So I could have just put -1 there. So if I graph all these three together, it will kind of look like this, except that, well, it'll be parallel lines. So let's go ahead and do that. So I'm going to take all of these and just put 0.3x in front of them. That's kind of cool. And one more. Okay, and so we can see the sinusoid. You can see it's increasing. Okay, there you go. And there's the bottom line, and there's the top line. So just by adding the same thing to each of those, it gives us that.
Mr. Sankey.